Previous lesson we looked at the concept of, or we were introduced to the concept of statistical inference versus descriptive statistics. In this lesson we're going to look at the two most common forms of statistical inference, which are the things that we'll be looking at for much of the rest of the term. So the two things we'll be doing in general are either estimation or testing. In fact, we'll spend probably more of our time on testing, but first we're going to look at estimation. But in this lesson, our goal is simply to figure out what's the difference between these two things. But again, let's emphasize the fact that these are both forms of inference. So estimation is exactly what it says. It's the act of estimating something, and what we'll be generally estimating will be either means or proportions. So what we'll be doing is we'll estimate, so let me see, let's put estimation. We'll estimate a mean or proportion. And remember, a proportion is just a percent, so like the percent of people that smoke or something like that. Estimate a mean or proportion for a population by finding the corresponding mean or proportion for a sample taken out of that population. A sample from the population. So what we then do is assume that if our sample is taken randomly, then it fairly represents the population. And so the mean or the proportion we get from the sample itself should be a reasonable approximation of the mean or the proportion for the population. Some examples of this might be things like political polls when they're predicting the outcome of a election, where they might say, well, it looks like 47% of the population is going to vote for candidate A and 43% for candidate B, or something like that. It could also come from some sort of a result of a study of behavior, again, like smoking or maybe talking on a cell phone while driving, things like that. Testing, on the other hand, it's still a form of inference, so we still use a sample, or in some cases multiple samples. And what we're doing when we're testing is we're determining whether there's a difference between groups or a relationship between variables. So determining whether there is a difference between groups and that oftentimes is just two groups, but it can be more. Or a relationship between variables. And again, it's oftentimes between two variables, but it can be done with more variables. We won't be doing that. We'll be using two variables at the most. So some examples might be looking at, say, differences in behaviors or disease occurrences between men and women, or maybe the incidence of a disease in smokers versus non-smokers, maybe a relationship between taking some particular vitamin and reduced incidence of some kind of health problem, things of that sort. So the way we can tell estimation, so when we're looking to try to determine whether we're seeing an example of estimation, is what we want to do is we want to look for a proportion or a mean. If a proportion or a mean is given to us, then somebody has estimated that proportion or a mean. And of course, it's only estimation if we're in a situation where we can't get the proportion or mean for the entire group we're talking about. So we want to see evidence, basically, for it to be estimation, we need evidence of sampling. If we wanted to find a proportion for some group and we could gather data for the entire group and determine the proportion, then we would know exactly what the proportion was. We wouldn't be estimating it. So again, if we're estimating, we have to have a situation of statistical inference. Now, the way to tell testing is, again, we want to look for multiple groups or multiple variables, and what they might tell us is that one group or one medication or something like that results in something that's higher or maybe lower, perhaps better, worse, different or not different. And so on. Or we could see there could be a discussion of a connection between variables, behaviors, so discussion of connection or relationship. Between variables. So let's look at some specific examples. So here are some that I've come up with. Some are a little silly and some are more realistic. Some of these are I made up, and others I found in books or on the internet. So this is the kind of thing you see every once in a while. You'll be watching television and you'll see an advertisement and it says 4 out of 5 dentists prefer Dazzle Bright toothpaste. So if we want to determine whether this is an example of estimation or testing, to see if it's estimation, we look and see if a proportion or a mean has been stated. And right here where we see 4 out of 5, that is a proportion. And so that indicates that we've probably had, this is a situation of estimating. Now we also want to remember that we're only estimating if sampling has occurred. And if we think about this, it's pretty unlikely that we would be able to contact all dentists, even if it were just in the US, in order to gather data like this. So this kind of a statement would have to rely on results from a sample. So again, we're estimating, in this case, a proportion from a sample of dentists, not all dentists. So this is a case of estimation. This next thing I got from the internet, I'd read and heard in various places that eating dark chocolate had certain health benefits, and so I just did a Google search for dark chocolate and health or something like that, and pretty quickly up popped something about dark chocolate and blood pressure. So here's what we have. A Swedish study found that small amounts of dark chocolate helped patients improve blood pressure control. So when we see improvement or better or something like that, you can imagine how they did this study. They probably had some folks that ate small amounts of dark chocolate and others that didn't. And that's what we will call a control group that doesn't eat it, and an experimental group. We'll go into that more later when we study testing in more detail. But anyway, what we see is if there's some kind of an improvement or a difference, so we see a difference or improvement for the folks that would eat dark chocolate. So that's an example of testing. And what we really want to think is that they were just testing to see whether eating dark chocolate improved blood pressure control. The next one I have here says results of a survey indicate that 57% of teenage drivers have read or sent a text while driving. So you can see the 57% here is a proportion. And so this is likely an estimate, and again, we wouldn't be able to get a hold of all teenage drivers. Plus, the group of teenage drivers is a moving target. There's new teenagers new children becoming teenagers all the time, and teenagers becoming adults all the time. So that's a difficult group as a whole to gather data from. So we must have gotten this from some sample. So again, we have a specific proportion obtained from a sample, so this is an example of estimation. Here we have the average age of the 240.5 million cars and light trucks being driven in the U.S. Says it rose to 10.8 years last year. So average age 10.8 years. So they're stating a mean in this case. So this is an example again of estimation. And again, it's not too hard to believe that there's no way they could gather this information from all cars and light trucks. So it must have been obtained from a sample. And let's look at one more. We see this kind of thing quite often. A clinical study indicates that a drug is not more effective than a placebo. So if they're developing a new drug and want to see whether it really does what it's claimed to do, usually they'll split people into two groups, a control group that'll take a placebo, which means a pill that looks just like the drug, or a liquid, whatever the drug is, form the drug is in, or some folks that are taking the drug. And so in this case, what they decided was that the drug is no more effective than a placebo. They're comparing two things, the drug and the placebo. So that's testing. They were testing the drug basically to see if it was effective. So an example of testing. So that concludes this lesson on the difference between estimation and testing. Remember again, estimation is when we estimate a proportion or a mean for a population based on a sample. Testing is when we're comparing groups or looking at variables and looking for a relationship between variables or a difference between groups.